Good afternoon, everybody. So in this session, we are very lucky to have two of the experts in data center design, building, and thermal infrastructure. We have Mr. Lukas with us and Mr. Chow with us. So could you please briefly introduce yourself to the audience?
Thank you, Savadika, and nice to meet you all. My name is Lukas Thalhammer. I take care of Hilti's data center business in APAC. So basically, Hilti is actually a supplier, solution provider, and also specialized engineering firm to make data center construction faster, cheaper, and more sustainable. Yeah. So a pleasure to be here, and happy to share a few of some of my reflections. Thank you, Joe.
Thank you very much. My name is Chow. Sawadee Good afternoon, everyone. I'm come from Malaysia, Enlighted Solutions in Berhad. So our company is a sales and trading and also more towards the solution on the air conditioning system. Our focus right now here is more to the buffer tanks. We believe buffer tanks have plenty room to grow but underserved categories. So we hope to help the Thais DC players to adopt one. Thank you very much.
Okay, thank you. So let's go to the first question. So right now we are facing an explosion in the AI field. So as a person working in this field, we can see that there's an evolution in terms of the models from deep learning based model to transformer based, and each model is like consuming 10 or 100 times more parameters, computational power. So that will obviously impact the way that we have to design the data center in the future. And so secondly, we also heard from the previous session that a lot of business begin to move from on-premise to cloud more. And then also we have technologies like code-assisted AI, which also the cost for the business in terms of if they want to migrate their current structure into the cloud. So it will be much cheaper. It can take like much fraction of a cost compared to like 10 years ago or something like that. So as we can see that we are going to need a lot of demands, especially in the AI-ready server. So from your point of view, maybe we can start from Lucas first. What do you think that we need to like redesign our current solution for data center?
Yeah, I think data center design from cloud to AI is a very exciting field, and especially for us thinking about how to optimize this kind of process, how to build faster, cheaper, and more sustainable. It's a very tricky question, and in fact, it's a question that I don't think there's yet one answer for. Why? Because at the moment, still around 90% of the build out is, as per my estimate and what I've seen in market research, cloud-based. Yeah? Only a small fraction is really AI-based at this point, and there's lots of talks and lots of players thinking about this. My take is that there's definitely quite a bit of change. So the overall footprint of the facilities may actually decrease, because there's more power consumed and used in the facility in a smaller space in the data hall. At the same time, I think there will be an increase in services coming in. Yeah, so we heard just now from the previous speaker about liquid cooling, and there will be also more electrical services, for example. So, on all of those services to manage this complexity within the facility, from the auxiliary area to the data hall and so on, is something that is, I think, keeping a lot of engineers busy, I shall say. And that's definitely one of the big trends. And then there's a few beyond that, but I'd say it's a very exciting field and still to be further developed and optimized.
I see. How about in terms of thermal infrastructure, Mr. Chow? Do you think it needs to be adapted for this change?
We are now in the AI era whereby the scalings and power usage is very tremendous. One GPU can consume lots of power, ranging from 60 to maybe a few hundred watts. So in a server racks, typical server racks, it can consume from 70 kilowatts up to perhaps 120 kilowatts. That consumes lots of power. This power translates into heat that must be rejected from thermal perspective or air conditioning perspective. That's why we traditionally data center is cooled by computer air handling unit as well as fan wall unit. So that might not be able to cope, I think, at this moment. So what is going to happen next? As time goes by, we are seeing immersed cooling, liquid cooling going into this era. And that heat is need to be rejected perhaps right now by cooling towers and dry cooler. Similarly, for aircon industry, that infrastructure need to evolve as well. We from air conditioning backgrounds, we also believe that buffer tanks is still looking relevant because of the tremendous high heat from the GPU, graphic processing units. That heat is tremendous. It has no way can be absorbed immediately by the chiller. So that spike had to be taken off by the buffer tanks that act as thermal inertia. This is what I believe. And next is buffer tanks in this industry can also buffer when during power outage. So it continue to serve while the chiller is down, and then genset need to provide power to restore back the chiller. The chiller will take several minutes to up back and further the cooling. This is how the buffer tanks provide valuable time to bridge the gap so that continuous cooling is still continue to serve the data center. And we believe buffer tanks continue to provide resiliency to the data center and still relevant.
I see. So from what I sense here is that there's some kind of gap here between the demand and the supply, right? So do you think the current players in the market, such as consultants, supply side, are ready for design change, Mr. Lukas?
Yeah, I think everybody in the whole industry is wrestling with staying relevant. Yeah, I think it starts from the hyperscaler about colocation, consulting, all kinds of contractors and so on. It's a race where, first of all, everybody wants to grow, everybody wants to take part of this boom. And then at the same time, one wants to hold up the quality and the standards and everything, and at the same time innovate. So all at the same time, I think is a very tricky thing to be done. And if you ask me if everybody is ready for this, I don't think so. Yeah, I think it's a start, an inflection point in the industry where I believe we will see more maturation. I think there will be more consolidation. There will be a few more players that will emerge successfully out of this, and others that may actually lose ground quite rapidly. Yeah, and the pace of innovation is just incredible. So for those of you who are not yet paranoid about your competitors, I think all of us, we should be. It's always something I say is we need to be ambitiously bullish, but also cautiously paranoid about the developments out there. Yeah,
very nice way to put it. What about in terms of thermal infrastructure, Mr. Chow?
Okay, from the perspective of aircon industry, to me, we can see that it advance of technologies from liquid cooling and suddenly turn once into direct-to-chip cooling as what is being presented. Thereby, transition is happening very fast in terms of months. To build a data center, it takes perhaps from 8 months to 12 or 14 months. By that time, their technology already expired. What they have purchased, what have they invested could be obsolete. So from my point of view, there could be lack of standardization. Each and every player is going out innovation very fast, very quickly. The standard need to be set, the benchmark need to be established so that DC operator, they know what they're purchasing, they know what they're buying in order for them to experience, to use, to test, and to maintain. Similarly, there's a gap also on computational fluid dynamics. Before the data center is built or is in the design stage, CFD already produced. But then again, how do we bridge the gap? How do we know whether the CFD really performs as intended in real time? This is where, back into Malaysia, we have to build our test rig, whereby client has the opportunity to see the real-time performance of the buffer tanks in comparison to the CFD results.
I see. Okay. And also one thing that a lot of clients also ask me is that every now and then, like every other day, we see in the news that everybody's creating new chips, like new models from China, from America. So as the technology of the software and the hardware, especially in the semiconductor industry, is evolving very fast, what do you think this will impact the way that we need to evolve in terms of data structure, infrastructure?
Yeah, I think, again, a very tricky thing and no final answer is there. What I would say is there's a few trends out there. One, for example, I can see is modularization. And with modularization, there may be some interpreting. There is a whole containerized data center, I think I saw from a couple of presentations, that is being deployed in rapid time. But it doesn't necessarily need to go that far. It could be actually two things when I think about modularization. On the one hand, it is modularize, basically make individual products and so on into complete solutions that can get deployed quickly. But also it is, for example, that we think a lot about the reduction of structural or welded steel. which is kind of hard to adjust. It has a lot of hot works requirements and so on. So we see a lot more like modular systems, like modular support structures, for example, coming in. Yeah. Or what also is important, you may at the time of the initial phase of construction not yet exactly know who is going to be your tenant, what are going to be your design requirements, and so on. So how can you define certain things in the beginning, and what do you not have to define in the beginning that you can still keep flexible? For example, even as topics as simple as passive fire stopping, a very critical thing that actually comes at the very end of the deployment and construction story of a data center. But then suddenly there's more cables to be run, and there's more and so on. So even clients that come to us and we try to help them about rethinking repenetration of certain things. How can it be much faster? The whole MRO side, how to support the data center once it's running, once it maybe has reached the end of its lifetime. It could be within a few years that new technologies are outdated and so on. And how do you make a brownfield site, meet the latest standards again and so on? And what can you do to adjust it? These are all questions that I think will get more prominence in the near future.
Sure, that's very insightful. What about you? What do you think?
From thermal infrastructure perspective, I believe the backbone of the system, the infrastructure need to be maintained and cater for full load. That one shouldn't be undersized. You need to cater for full load of the building for the data centers. Perhaps it can be staggered in expansion on the data halls in terms of IT load, as well as the chiller plant capacities, perhaps batch by batch delivery in future next 2-3 years. The backbone must be sized correctly to cater for maximum load. That's one of the strategy. Second, there should be provision for future tapping off with the pipe sized correctly that allow for future expansion in terms of modularity, so that the DC operator have chance to expand the IT floor by floor or zone by zone. If the technology advances too fast, they choose to adopt, or they would like to try to adopt new technology, they have a chance to do so. They can split by a small scale, new cooling tech, and install at a certain area, and then they see for themselves, they test it for themselves, they run the system for themselves. If the result is positive, they can duplicate the same concept using the newer tech into another zone or another floor. That will be helping to keep them abreast with the technology.
How about in the aspect of sustainability? How do you see this trend impact the way we design the data center?
Yeah, no, very good question, Joe. I think sustainability is something that is there, will come, and will increase even more. And earlier, I think there is a little bit of a perception that sustainability means green power. It means just sustainable resources, solar power, water power, wind power, and all that will supply the energy for the data center. But I think we are way beyond that already. There's more discussion on, the water efficiency use. Is there a recycling of water? That's one sustainability element that is not measured in CO2 tons generated. But there's also other elements in CO2 generation that are important when it comes to embodiment of CO2. Yeah, so I can even see, as of today already, hyperscalers, but even colocation players assessing during the process of construction and during the materials being used as part of the data center, what type of CO2 footprint is there? What is the ton of CO2 generated for the steel ton that you're using? What is the ton CO2 generated for the ton of cement being used? Topics that previously were not on the agenda. So for me, this is a very exciting area. And I'm from Europe. So this is always a huge topic all along. Maybe in Asia, a little bit less at this very moment, but I believe also US, it's there. And whether it's always on the highest agenda of the political, forces everywhere, that's a different story altogether. But I think the industry in itself has it very high on the list.
I see. What about in terms of thermal infrastructure, Mr. Chow?
First of all, we look at the word of sustainability. Sustainability means to use the resource for current, however, still preserving without sacrificing or compromising the needs of resource for future generations. I think we have already the KPI in place whereby we can see we have PUE stand for power usage effectiveness, water usage effectiveness, as well as carbon usage effectiveness. That is a benchmark. That's the indicator need to be assessed and apply to the data center itself to see where's the position they are in comparing and benchmarking the universal line. This is first. Secondly, on buffer tanks, we believe a buffer tank has room to place because it can absorb erratic spikes of the heat without creating too much burden to the chiller. Chiller normally they have a protective algorithm whereby they wanted to prevent surge and also to prolong the longevity of the compressor. Some chiller we have multiple compressor also and running in hard load. We also do not want that the compressor to trigger cycling on and off. By lessen this possibility, the chiller can stay at hard load longer and hence save energy and prolong the life of the equipment. This is where we build on the sustainability. Secondly, by making reference to the S-Ray TC 9.9, it's a thermal operating envelope. There's a lot of room to expand. We are not limited to certain operating conditions. However, this one needs to work hand in hand with manufacturer on the far side to see where's the limit of the hardware and where it can operate at the higher temperature without compromising the reliability and the performance of the hardware itself or of the IT server rack. So this is a second point. The third one is that perhaps there's lots of heat we can recycle from the GPU. I think studies is on the way on how to harness and harvest the base heat and recover it for reuse.
And maybe I just add one more comment there. I think it's amazing. Whenever I attend a conference, there's always a lot of learnings that I take away. So I've never heard of carbon usage effectiveness before. So thank you for sharing this while I'm sitting here, as well as the technology around the buffer tanks. But I think for all of us, it's part of the duty and the responsibility to stay up to date, even if it's a challenge in a dynamic industry like this.
So thank you very much, Lukas and Chow, and thank you everybody for joining. So please enjoy the rest of the conference and please give a round of applause to Mr. Lukas and Mr. Chow. Thank you very much.